So we'll be looking at introduction to R, installing R for those who have not installed before, and then we will run through this overview. Now, as a matter of fact, R is a worldwide language for statistics, a very strong one that is good at predictive analytics and data visualization. So if you are looking for anything, data visualization, data analytics, predictive analytics, you can count on R. It's an interactive and the best way to learn, because R is interactive. So if you want to learn it, you have to experiment it. You necessarily must experiment it. It's a programming language and it's an environment for statistical computing and very versatile, extendable, and it is community driven because we have different communities of R developers, different. I think we were told at the time that we have R ladies in Abuja. So we have different communities, that are into the development of R software itself. All right. So another beautiful thing about R is that it's open. It's an open source software. And we are in Africa. One of the things that Africans, is if you have to pay through your nose to get software, that's already a limitation. But we don't want the R software already bypass that limitation. So in this course, we provide you the skills that is needed to master this comprehensive software and to apply it effectively to your data. Now, data analysis over time, which has been the core interest of statistics, has actually changed over the years. And, with personal computers and internet and the kind of volume of data we have that has grown enormously. Companies have their data in terabytes and a lot of data available there. Now, gleaning information from this massive store of data has become an industry itself. And at the same time, presenting information in easily accessible and digestible ways has become increasingly challenging as well. So the science of data analysis, which we can find in statistics, psychometrics, econometrics, machine learning, also has kept pace with this explosion of data. You would realize that this process that we highlight here is involved in, these steps are involved in typical data analysis. For instance, what you have is that you have to bring in your data, import your data, you prepare, exploit your data, clean your data, and then when you have your data ready for use, you want to fit the data to a statistical model. If the data fits well, that is, you go to evaluation. Okay, so in case you have not been able to download your R, please, you should signify. We have it on the hard drive. They can help you to quickly send it. So you see here that, so after you have prepared your data, you've cleaned it and all of that, what is next is that we have been talking about fit statistical model, or it can also be mathematical model as well. So you want to fit your model and then you evaluate it if the model fits well. And if the model does not fit well, you go back and refit. Or you check your data again. If the model does not, sometimes, you may want to check maybe we have missing data and you have not properly cleaned your data. So maybe that's why it's not fitting well. So you would want to go back to check, maybe you have to clean the data again and then check again to refit again. So until you are able to pass this stage, when the model is judged to fit well, then you can now move on to the cross-validate the model, where you begin to check with real life if your model is saying the same thing with what real life is saying. And then with that, you can then move on to do your model prediction and then produce reports. So this cycle is what the process involved in data analytics. So which the advent of personal computer and especially the availability of high resolution monitors, has also had an impact on how results are understood and presented. So a picture really can worth 1,000 words. You know, one thing is that what you can see sticks better. So the issue of visualization that R provides is one powerful thing that we enjoy also in R. So, and human beings are very adept at extracting useful information from visual presentations. So we have modern data analysis, increasingly relies on graphical presentations to uncover meaning and convey results. So to summarize, today's data analyst needs to be able to access data from a wide range of data sources, which we can talk about database management system and other kinds of data sources that you can talk about. They need to merge the pieces of data together. You have to clean, annotate them. You have to analyze them with the latest method. Present your findings in meaningful and graphical appealing ways, and incorporate the results into attractive reports that can be distributed to stakeholders. So as you see later, R is a comprehensive software package that is ideally suited to all these goals we have highlighted. So it's a language and environment for statistical computing and graphics, and similar to S language, there was a language before called S that was developed at Bell Lab, and that was, but most of these ones were proprietary. You have to pay. So, but now you are having something that is open source. So it's open source. So it is an open source solution to data analysis that is supported by large and active worldwide research community. All right. Now, a lot of other things. Now, we have been talking statistical, even as mathematicians, a lot of modeling that we are talking about are done using the R platform. The model fitting and all of that, the simulations are done in R, on our platform, and beautiful results you will see. So there are many other popular statistical and graphing packages available, which we have Microsoft Excel, you have SAS, you have IBM, and a lot of them. So why R? Why R? Now I've talked about it. Why? Explaining. It has many features that makes us to recommend it. One, most commercial statistical software platform cost thousands. Imagine that you have to pay in dollars, and because you want to be a researcher, and you know how much you are earning. It's not for us in Africa. I think research should be free. Yes. So if you have open source softwares like this, they will help help us in research. And then it's a comprehensive statistical platform, like I've said, offering all manner of data analytics techniques. And just about any data analysis can be done in R. It has state-of-the-art graphics capability. If you are talking about graphics, then R is very superb. Very, very superb when you are talking about graphics. All right? So, if you want to visualize complex data, it has the most comprehensive and powerful feature set available. All right? And it's a powerful platform for interactive data analysis and exploration. Now, from its inception, it was designed to support the approach outlined in one. That's the flow diagram that I showed you, the process involved in data analysis. So that's what R was actually designed to be. So, for example, result of any analytics step can easily be saved, manipulated, and used as inputs for additional analysis. All right. So again, we are saying why use R. So again, getting data into usable form from multiple sources can be very challenging. So, but R can easily import data from a wide variety of sources, which will be seen as time goes on in our training. You can import your data, different kinds of data, CSV, Excel, Stata, name it. You can import them into R, and R supports all of them. So database management system, statistical package, and specialized data repository, it can also write data out to these systems as well. You can write out your data in Excel, you can write it out, So it provides an unparalleled platform for programming new statistical method. in an easy and straightforward manner. So, and it is easily extensible and provides natural language for quickly programming recently published methods. Now, still why use R? Now, I'm just trying to whet your appetite as you go into the work. Now, it contains advanced statistical routines not yet available in other packages. In fact, new methods become available for download on weekly basis. On weekly basis, you have, a lot of updates because there are people who are working on it. We have communities of developers who are working on it from time to time. All right. Now, if you don't want to learn a new language, a variety of graphic user interface, which that was why we are talking about RStudio. RStudio is a GUI. Is that okay? It's a graphic user interface that actually makes coding in R easier. Okay, you have menus, you have dialogue, but for you to be able to understand what you are doing, as you will soon see. So it runs on a wide array of platforms, including Windows, Unix, Mac OS, and then it's likely to run on any computer you might have. All right. So yeah, some even have it on iPhone. We have iPhone. So, but I don't think you want to look at that. So now for R graphics, one of the things that you can create, a beautiful graphics. For instance, now you see one now which I will not talk about so much because I have not, talked about how to go about that, how to plot such graph. But there's a graph you see now. This graph, this same graph you are seeing here, was actually created with a single line of code, and that describes the relationship between income, education, prestige for blue collar and white collar, and professional jobs. So it's actually a scatter plot matrix with groups displayed by color and symbols. Okay? And the largest outliers in each scatter plot has been automatically labeled. If these terms are unfamiliar to you, please don't worry for now. Just whetting your appetite. We'll cover them later. So for now, trust me that we are really cool, yes. And I believe you should be salivating by now. All right. So now, like I said, I shouldn't talk so much about this graph, but we'll come back there later. Now, there are some interesting, okay, this is still talking about that, that graph. Okay, so we have much to say about this type of graph later. And the important point is that R allows you to create elegant, informative, and highly customized graphs in a simple and straightforward fashion. So creating similar plots in other statistical languages can be very difficult. It can be time-consuming, or it may be impossible in some cases. All right? Now, R, as beautiful as it is, has its own, steep learning curve as well. Why? In fact, one of it is that because it can do so much, so the documentation and the help files are very, very voluminous. So you must be such who is ready to pay attention to details. You must be such who is ready to read along, the in between lines and all of that. So, but that's not a problem because we are people who want to learn. So we'll be able to bypass that. Again, we have so much functionalities that come from optional modules created by independent contributors. So this documentation can be scattered and difficult to locate. But in the course of this training, today we'll see how some of help, can be sought. So getting a handle on all R can do is a very big challenge. So the goal of this course is to make access, to R quick and easy. Yes, so we'll tour the many features of R, covering enough materials to get you started on your data with pointers on where to go when you need to learn more. Yes. So, yeah, for the installation, for some of you who have installed, I want to, if you have not installed, please signify so that people can help you. So, I wouldn't talk much about the installation again because we have done the installation, and then there are two things you install. Now, if you install R alone, you can work on it. There's no problem. But the challenge is this. Now, the benefits that you have in RStudio, you will not have it in R. For instance, If you are typing and you by chance close your laptop, you know, whatever you type is gone. And if God helps you, you have been coding from morning, and then you by chance something just happened, the thing closes. That's all. It's gone. It's gone for life. But you know, on RStudio, you have it there. You can return. You have it saved for you. So RStudio being is a GUI is actually a platform. And then when you download your RStudio, you have something like this. If you have, now everybody open your RStudio. Your RStudio. Everybody open your RStudio. So we want to see the interface. You should have 4 panes. Now when I say 4 panes, I am talking about each. Please each of these, there are about 4 compartments here. Is that okay? The panes. There are 4 panes. All right? So now if you have 3, look at the icon for minimizing and for maximizing. It might be that you have maximized one to cover the other. So try to click on that and then the other one will show. Okay, I don't know if you are not seeing this one. Please let's be together. So if you are not seeing now you realize that the 4 panes, you have 2 on the left hand side and 2 on the right hand side. But let me see on your left hand side, how many do you have? You have 2, right? On your right hand side, how many do you have? 2 as well. So if you don't have that, call for help. They will help you to bring it out. All right? So we have what is called the console. Is that okay? The console is on your left hand side, is the pane that is down. The down pane on the left hand side is the console. And that is where, you know, please let's be together. So the bottom left panel console is is exact same as the standard R console. So if you look at that one, if you open R and not RStudio, this is what you would have obtained also. So R only provides you with the console alone, while the RStudio provides you 3 other additional panes to be, you know, you can see at a go. All right. But in RStudio, whatever you are typing now, with the top panel, which is called the editor, that is where you write your scripts in R, and then you can have your results displayed in the console, which is the one down. All right, so this is what I'm saying. So let me go to my R. All right. Okay, so just want to drag it a bit down. So here you have your the editor. Is that okay? Now in the editor, you can always open a new R script, or you press Ctrl+Shift+N to open a new script. All right, is this thing displaying? Mr. Sam? All right. So either you press Control Shift N, to open another script, or you go to File here, and then you click New File, and then you put R scripts. So you can see that the shortcut is already in front of it. Control Shift N. So of course that tells you that next time you want to open a new file, you don't need to go through the file, just put Control Shift N. So that gives you a new script entirely. So this is where you have your console. This is what we call console. Let me clear the console. All right. So when you open, so you are supposed to have this. So this is the console. This is the console. This is your editor. Is that okay? This is the console. This is the editor. The editor is where you type your code. Is that okay? Are we together? You may want to see, for instance, if I put 2 plus 2. For instance, now, if I want to run, now you can see run here. Can you see run? Or you just press. Now, as I placed it there, it also gave me the shortcut. So meaning, what can I press if I don't want to click that run? Control Enter. So if you do Control Enter on where the line of this code, where it is the cursor is blinking, just press Control Enter. What do you see in your console here? Is that okay? What do you see in your console? One, it first gave the code that you typed, isn't it? With a sign that is like greater than. Do you see a greater than sign? Okay, so that's a command prompt. We call it what? Command prompt. So on a normal day, I can type that one too, directly into R console. If I want to type inside R console, look at my console. Can you see that command prompt? Where the cursor is blinking, I can just do 2 plus 2 there to the same thing that I typed before. And then if I do that, I just press Enter. In that one, you don't need to do press Control Enter. Enter is enough in that case. Is that okay? All right. Okay. So please let's be together. So meaning that everything you are doing in the scripts, you can do in the editor, you can do in the console as well. The only challenge is that if you go and type, now if I close this now, please let's be together. Now, even if I save this, if I close this now, the one type in the console will go away. Right? It's the one that is typed here in the editor that will remain. So whatever you type in your console straight, once you close your laptop, it is gone for life. Okay, so you want to type in your editor. All right, thank you. Okay. Now, there are other interfaces there. So the one we call workspace and history, right? Now, if you look at this, all right. So now you will see something here. We have environments. Do you have it? You have history. So in this place, please let's be together. Later we'll learn about this environment, right? Everything that you have worked on, that you have saved, now you can access them in your environment. Is that okay? And the history just shows what has been done. You know, this person, you see now the 2 plus 2 that I have done. Do you see it has joined it? The history is showing that I have done what? 2 plus 2 as well, isn't it? Okay. Okay, yeah, thank you. All right. So there are other things we can do with that pin, but we'll be talking about it later. Okay, so the other one is what we call files, plots, packages, and help pane as well. So if you go here, you will see this. Can you see this place? You have your files. Here you can access your computer from this place. If you click on files, you can access your computer from this place. You can see many things in here, right? If I want to access any, so I can click here. You see, it's opening something for me, right? So you can access your computer from that place. Your plots, if you have a plot like this computer, maybe there's a plot ongoing here now. I mean, that's here now. You can access your plots will be shown here, and we can export our plots. We can export it if you want to, either as image or as what? PDF, or as what? We can copy it what? Clipboard. But most times I use either of these two. Okay. All right. Thank you. Now, in case you have questions along the line, please don't hesitate to ask. All right. So now working with R, you should know R is case sensitive. R is what? When you are supposed to use lowercase and you use uppercase, it will throw error at you. Anyway, I've always said error is good. So when you get error, you should rejoice. Yes, the reason is that, you know, one of the things you have to learn is that when you have error, you just read the error message. You learn, you get yourself familiar with error message, how to interpret error message. If not, you know, when you are, just like mathematics, when you are solving math and you are getting it, you are fine, right? In fact, you can continue without eating. You would have forgotten that you are not eating. But when you start solving one and it's not working, okay, the kind of sweat, the kind of tiredness that will come on you as if it's the same thing with coding. Oh, when you are coding and you are just doing it and the result is flying in and the plots are coming in and they are flowing in, you enjoy it. But when you click Control Enter, bam, and the thing is red, you have plenty red in your console. So then you will understand your body go day. So, but it's not bad. You learn to read those error messages so that as to debug your code. Is that okay? All right. Now, I've told you before that working with R, you can enter command, you know, one at a time after the command prompt, but that is if you want to work with the console, but now we want to work with the script, right? So you don't need the command prompt before you type. Just type wherever, you know, the next line. The next line, I can type anything there again, and then I can execute it. All right. Okay. So there are different data types that we'll be looking at later. All right. And also we will be talking about, you know, the most functionality is provided through built-in and user-created functions in R. Now, there are functions in R. For instance, we have what is called the built-in functions. For instance, if I want to get the mean of certain numbers, mean is a function in R already. It's an inbuilt function. It's built in there. But other times, for instance, you may have customized function that you want to create yourself. Is that okay? Now look at maybe for mathematicians, you work with a lot of functions, right? Mathematical functions that you want to create yourself. So you R permits that as well, to create functions for your own use, customized ones. Okay, so for instance, if I come here now, once I begin to type mean, you see, R will suggest it already for me. Do you see that? And if I click enter, it brings it in. And it's telling me I should put mean of what? X. Can you see on top of it? So meaning I should put mean of certain thing. The data that I want to find a mean, that's what it's asking for. So because it's a built-in function, it recognizes the mean. But now, if I want to build a function in there now, I will have to create it myself. If it's not something more than mean, that is, it's not in there. All right, we'll see that as we go on. Okay. So basic functions are available by default. Other functions are contained in packages, yes. So in R, you have a lot of packages that you'll be dealing with, packages. Why? Because there are special functions that you may need to use that are built in some packages. And so we'll be talking about installing packages. And so some of them can be gotten. You may not be able to access some of those functions except you have first installed the package. Are we together? Mean that I type is by default there. It's in the base R. That's why you saw that when I type mean, look at it. I want you to see something. Type it. You can try it yourself. Type mean. Now, what do you see in front of it? It says base, right? That means in the base R, it's already there for you. Is that okay? Now, I want you to see some other functions here. Look at this one now. Mean CL, mean underscore CL underscore boot. What do you see there? ggplot 2. That means that function, if I want to use it, where will I find it? It's found in ggplot2 package. So I cannot just use it except I first install ggplot2 and I load it. Is that okay? So that's the difference between the functions that are in the base R and those ones that are special that have to come with packages. Are we together? Okay, go ahead, sir. Okay, I said you should type here mean. Have you typed it? Mean. Right? It should bring out a prompt. But you didn't see mean CL on the right? It's because you have not installed it. This person has installed the package, right? So as many packages you'll be installing, we will tell you about it. Like and with practice, you will know what package to install over time. Is that okay? We'll install some here. Okay, let's move on, please, for time's sake. All right. Now, please let's pay attention to this. We are going to do something now. Working with R, we said statement consists of functions and assignment. Assignment very important in R. In math, you are used to let X be, right? And when you say let X be 2, if I have X plus, if I say let X be 2 and Y be 3, X plus Y is what? Am I seeing X plus Y again? In place of X, what am I seeing? 2. In place of Y, what am I seeing? 3. So in the memory of R, when you assign something, is that okay? So let's go there now. For instance, let's go to R together. Now, as we have put 2 plus 2 the other time. So let me say X, right? I want to assign. The symbol for assignment is, you can get it through, you can say ought minus. If you do ought minus, it's going to give you this less than and minus. And you can also type it separately. You can type less than what? Minus in front of it. But if I do ought minus, it's also going to generate what you are seeing here, this less than and minus. Is that okay? If I say let X be equals to 2, do you see X equals to 2, right? That is, I'm assigning 2 to what? It should keep in its memory that X is 2. So if I run it now, look at this, let's run it. Now, unlike the first thing that I did, the first one that I did, when that I didn't assign, I said 2 plus 2, and it just gave me both 2 plus 2 and the answer, right? But this time around, it only gave me what? The same code that I typed. Is that okay? But it has kept it in its memory. Let's go and see if it's in memory or not. Let's go to environment. Can you see X equals to 2 here? X is what? Kept as 2. It has kept it in its memory as what? 2. So henceforth, if I just say x plus 10, right? X plus 10, and I run it now, what do I have? 12. Because it already reckons with x as what? As 2. So you assign variables. Please, let's be together. You assign any variable, to whatever you decide to use. In fact, from now on, you can use your name. Let's say your name is Ade, right? And I want to assign Ade to be what? Minus 20, right? So when I run this, it has assigned Ade to be what? So can you see in the environment already? Ade is what? Minus 20. Do you understand? So if I say Ade, which 2 times Ade now, okay, I will be using this asterisk. So, and I run, what do I have? Minus 40. Do you understand that? Are we together? Are we together? Okay, please, if you are not with me, let somebody just raise your hand. Somebody should help you. I have said once you are at a point you are not getting what I'm saying, just put up your hand. People are around you to help you. See what's just they are around you. So just put up your hand. Somebody will help you. Please, I want us to maintain decorum as much as possible so that we will all enjoy this class. Just put up your hand is enough. Don't talk so that we will not distract ourselves. Now, so let's assign S to R norm 5. This code now. Yes. So let's assign. Now, one good thing in R is this. If I assign X as what? R norm 5, it will replace it. Now, S has been assigned to be what before? Hello, let's be together. S has been assigned to be as what? Now I'm using the same X. That means I want to overwrite whatever X was saved as. Now we explain that. This is just, I'm saying this code, just you will see much of it later. But this one is that I'm talking about randomly generated numbers that follow what? Standard normal distribution. I want to generate 5 randomly generated numbers that follow what? Standard normal distribution. If I want it to be other normal distribution, I will have to specify the mean and the what? The standard deviation. But now since I didn't specify the mean and the standard deviation, it takes the default, which is the what? Standard normal normal distribution, which is with what? 0 and 1. Is that okay? All right, thank you. So if I run that now, it will replace the X there. But if you don't want a replacement, you can use another letter. We are not glued to X, right? We are not glued to, so you can use anything. Like I told you, I said you can use your name. If you so much like your name, you can use it. Use your name to save randomly generated numbers, right? All right, can we go on, please? Okay, so I will use X and then I will show you that just to, again, confirm to you that you replace, confirm with me, what do you see S save as here? Originally save as 2. So let me run this one now. What do you see? Once I run it, what do you see X has changed to? It's telling me there's a number. How many numbers? 5, 1 to 5, right? And gives certain the numbers. Now, I'm not seeing the results, but I can see it if I want to see it, right? No, more compare. I just want them to see it better. All right, can you see this now? Okay, please, let's be together. So if you want to know what X is, 2 ways. Either you press S itself. That is where we want to call it. We want to call the values that X. So we can just type X and then control enter again, and it tells us what the values are. Or you say print X. The same thing it will do if you say print X. If you say print X, it will do the same thing. Right? Is that okay? Yeah. So those numbers were randomly generated, and it follows normal distribution, standard normal distribution. Are we together? Okay. So what we are saying is that I've just talked about the issue of assigning, of assignment. Is that okay? Are we together? So I have assigned to X 5. I've created what is called vector object now. Are we together? That contains 5 randomly generated numbers from standard normal distribution. Okay. This is okay. Yeah, I said you could just type X alone and run it. It will generate the same result as print X. X to 2, I assigned X to 2. Then X to randomly generated number. 5 of them. I want to, now, if I have put 20 here, for instance, it will generate 20 numbers. Randomly generated 20 numbers. So you can try. You can put anything there. Just put 100, but it has to be positive integer. Yes. Because you are talking about numbers of outcomes that I should generate for you. Randomly generated numbers. I want 20 of them. So if you run this one now, you have 20. Do you have 20 numbers? Do you have 20 numbers if you do this? Try it. Try it. Lay your hands on something. Try it. Make mistakes. It's good. It's part of it. Do you have 20 numbers? Great. So they are randomly generated, and it's from standard normal distribution. Okay. All right, let's move on. No time on our side. I have thought I will be able to finish this. Okay, now that same, please let's pay attention. That same thing that you have done, you could also have used equality, but equality is highly discouraged. Yes, because, please let's pay attention. Equality can also be used later when we are talking about operators. So we don't want to confuse them. Is that okay? Yes, R operators. Equality is one of them, and we don't want to confuse it with assignment operator. Is that okay? So it's good. It's a good practice that you stick to this one. Yeah, it's just always encouraged. Now, another thing is this. A very good practice. Please, let's listen. Now, when you are typing code, as you start, we will soon start now. Now, the code can become plenty and then become very complex. Now, you need to be able to write notes of what you are doing, the steps that you have taken. Are we together? So that when you go back to your code, you can remember what you did. If not, when you have typed plenty codes, the day you want to return to it, your own code that you wrote yourself, it will look strange to you. You will not remember what you did. Are we together? So you can write comments. Are we together? So let's go write comments, for instance. So I will say, let's say I may want to write in front of this. So I put hash. Mr. Sam. Sorry, I'm not using my system, so. Okay. So hash. Anything I type in front of this now becomes what? A comment. So assigning, you can type it. Assigning what? 2 to X. So when I go there next time, and I will say that this guy is my assignment operator. Is assignment operator. Right? So it's saved there. You can see that it's another color. Yes. So it's saved in the memory as what? It's saved as what? As comments. It's not going to be executing that as anything, as any code. Okay. what? I've said it now, less than or minus. Either less than or minus, or what? What minus, it will give you that. Okay, can we go on now? I have just 2 minutes to leave this place. And I have a long way to go. So we have to stop it wherever we stop. Okay, please, let's be together. This one is going to be the last thing we'll do for today. And then we'll call it a day. Now, please, let's be together. Yes. Yes. Very important. So, yeah, somebody was paying attention to the board, to the screen so closely. So, just the same way you said x equals to 2, you can say what? 2 is what? 2 is assigned to what? X is the same thing. Right? It's the same thing. All right. Okay, thank you so much for that. Now, let's be together. Let's be together. Let's be together. Let us be together. All right. So if you are using Windows, you can launch R from the start menu. Yes, as you can see, you see your RStudio from here, for instance. Or so please, this one we have actually gone past this. So now let's say that you are studying a physical development and you have collected ages and weight of 10 infants in their first year of life. So let's see the table. So you are interested in the distribution of the weights, their relationship to age, for instance. So let's see this. So this is what I'm talking about. You have this table before you, right? Now you have age and you have what? Weights. So we want to, now how was this table created, or how can we get this data into our, we can, now please let's pay attention. Now, you can enter the age and weight data as what we call vectors. As what we call what? Vectors. Yes, and you use function small c to, now let's be together, to create a vector. To create a vector, this that we are seeing here is called concatenate. It's called what? So you use that to combine numbers. Are we together? You use it to combine what? No. Now look at on the weights. Look at on the age column. You have number 0, 1, 0, 3, 0, 5, 2, 11, 9, 3, 9, 12, and what? 3. Those are numbers, right? Now, we want to put them together because they belong to the same column, right? So we want to create, so itself, each of this column itself is actually a vector. Are we together? Each of the column is a what? Vector, because it contains different numbers. So let's first create that as a vector, and then age as, weight as well, as what? As a vector. Now, will you, okay, please permit me to just carry out this and then let's end the class. I've already gone past my time. So please, let's do this. Okay, so you enter the age and weight data as what? Vector, using this function. It is small letter O. If you use capital, it's showing you. No, I'm not typing yet. I'm just showing you this. So if you use capital, you are going to get error, right? So it combines its argument into a vector or list, right? Now, what we want to do, we want to get the mean, we want to get the standard deviation of the weights, and we want to get the correlation between age and weight, and we want to plot the relationship between age and weight so that you can inspect any trend visually. So let's look at this. So this is what you are going to do now. Everybody type age. This is what you are going to press in your editor now. Age. Don't mind the command prompts now. Don't mind the command prompts. You don't have to type the command prompts. Is that okay? Don't type the command prompt. Everybody, let's go, let's go, let's go. Age assigned to, you don't need the command prompts. In the RStudio, you don't need it. You don't need it. You mean it? Okay. Sorry, I'm not doing off this laptop. Please, don't worry, say I should enlarge it. Can you see it? All right, so can we go on now? Now, still on this, I'm saying let's start. Age. So small, lowercase c, right? 1, 3, 5, 2, 11, 9, 3, 9, 12. Now, once you do that, run it. If you create a line of code and you don't run it, R has not recognized it. Because it's not yet saved in the environment. It's not recognized. So if you later call for it and R is telling you, it's not available, it will throw error at you because you are calling for something that never existed. So you must run each line. Anyway, another way is to highlight all and run at once, but the challenge is that if you run into error, you will not know where the error comes from. So it's not a good practice. Run line by line so that you will know in case you have error where you need to, which line the error is coming from. I have told you, don't put the command prompts. Don't put the command prompts. This greater than sign that you are seeing, don't put it. The greater sign that you are seeing there, you don't need it, right? This is showing you a picture of what has already been, what we have run, and the outcome is just showing the console, what has happened in the console. So I want you to, you are typing age, run it. Type weight as well, run it. I have told you if you need help, it's simple to raise your hand. Just raise hand, please. Don't let's talk so that we can enjoy it together. Don't talk. Same C, yes. C is to combine them. It's called concatenate. Is that okay? It's to combine the numbers together so that it will see it as one entity. When you now call age, it sees it as the entire thing. All right. Okay. All right. Are you there? So now, I want you to find the mean of the weights when you are done by just typing mean and weights. Okay. You mean you can't still see this? What should I do? Can you see? I should still increase more. Sorry, the last one is 6.1, not 6.11. Oh, that one is cursor that was mistakenly captured. The cursor was, this is a picture, so it was mistakenly captured. That's a good one. Clap yourself. Somebody has got error here. Let's clap the person. We have error. That's a good one. You are becoming a good programmer. Now read your error message. Read your error message. So you yourself will be able to know what is wrong. Somebody is with you, but help her to read our error message. That's a good one. Object weight not found. That's good. That means you did not run your weights. You didn't run it. I told you run line by line. You did not run it. R does not lie. R does not lie. So, 6.711. You are wrong. What did you get? If you got 7.06, where are you? Oh, clap them, clap them. You are owing me something. You are owing me something. Don't worry, let's get there. Somebody is jumping. Somebody has plotted the graph already. Can we end the class? No, we must end the class. All right, can you get, so who has already gotten the standard deviation? Okay, what do you have your standard deviation? All right. Now get your correlation. Get your correlation. Done. So if you want to interpret this correlation, what does it mean? That means there's a strongly positive what? Correlation between, relationship between what? Age and weight. All right. It's not relationship, it's association. No. Wait, don't, that Q in bracket. Once you type Q in bracket, you are saying quit. So don't run it yet. That's why you should be careful. Don't jump. Don't jump. Once you do that Q, you're asking the program to do what? Quit. But I want you to save it first before you quit. Now, you can also put the plot. Says you plot. Now, this plot that you have there is the most basic thing you can ever do. You can decorate this plot as you want, and we'll see that later on. You can put many things on your plot. You can present the plot the way you want. We will see that later. But when you use plot like this, it will just give you a scatter plot. It will give you a scatter plot, which is the most basic outputs or plots that you can see in R. But in case now, for instance, I don't want to see scatter plot. I may want to see that, solid line. I may want to see that certain color. I may want to put X label. I want to label my X and Y axis. I may want to label the whole plot itself. I may want to use different plotting character. R, you can get a lot of that. So, but at least let's start like this first. All right, so let me believe that you have done that. Great, great. All right, now let's save our R before we go. It is a good practice to save your. It's a good practice to save your. All right, so let's say I am here and I want, if you look at it, it's bringing on title, right? It's bringing what? On title. So please do something for me now. Do something for me now. Go to your desktop. Go to your desktop. Create a folder there. Create a folder in your desktop like this. You know how to create a folder already. You can call it R file or my R file if you like. Just go to your desktop now. The desktop, just go to your desktop in your laptop and create a new folder. You can call it, so save it, call that folder R file or my R file, whichever way you want to call it. Are you there? You can create that folder as well, but just put it on your desktop for now so that it's easily accessible. Are you there already? Okay, so we created that already. All right. We want to save our place. We want to save our R code there. So let's save it as my first R code, for instance. So I will come here and click Control S. Control what? Control S, then navigate to your desktop and go to your R file that you have created. right? You know how to save now. Hello? Now listen. Let me go back. That's why I said don't let us make noise so that we can get it. The way you are making noise, you cannot get a lot of things. Let's not make noise, please. Can we be together, please? Please let us be together. Everyone, let's be together. Thank you. You have created a file on your, a folder rather on your desktop, right? You have named it something. Maybe R file, right? Or R files, whatever. Okay. Now I ask you to go straight to your scripts. See your scripts here. Can you see your scripts? So you can just do Control S, your normal Control S that you are familiar with. Are we together? So it's asking you where you want to save your. Where do you want the work to go to? I want it to go to what? Desktop and what? Is that okay? Are we together? And what? So I want it to go to R5. And I want it to be my first R code. My first R codes. Right? And I'm clicking on what? Save. It has changed it from what? From what? From untitled to what? My first R code. And if you now go to your desktop and open it, you'll see it there. So if you come here now and open it, you will see that you're having what? My first R code, which you can open any day, anytime. Is that okay? Later on, we'll teach more things around working directories and co. All right, thank you so much for staying through.